Good morning, everyone. In this video, we'll continue our discussion with the introductory basics. We'll be specifically talking about network basics. Okay, we'll be discussing several subtopics of networks as part of this video or like this basic bunch of videos. So we'll be looking at network protocols. Okay, what is network architecture, and I will also discuss about TCP/IP protocol suite. Okay, and how we can identify these network resources and addressing these internet hosts, and we'll also be discussing about domain name system DNS. So let's start with this one. So we actually have seen like distributed systems are mostly network based applications. Okay, and most of these applications are provided over the internet. Okay, so internet actually requires some common set of rules actually specified for exchange of this data. So we also have discussed like these distributed applications, okay, distributed system based applications, okay, uh, will be existing across the network, and then like they will be communicating by exchanging the messages. Okay, so that we have already discussed. So when they are exchanging the messages, they are actually exchanging the data. So basically, like when you are exchanging the data, you actually need some sort of rules using which like you actually follow these rules or protocols. You will actually follow so that like you can actually send this data in a proper manner. So the rules or protocols actually specify the matters such as formatting. Okay, so how you actually format the data which you are sending to the other machine. Okay, and the semantics of data, what the data should contain, and flow control, so how the message should be going, okay, across these machines. Okay, and then like what happens if certain data is actually lost, error correction. Okay, so all these things like you need some sort of rules specifying for that one. These are actually called the protocols. So basically the software which is actually being developed can actually share the data over the network, okay, by using this sort of network software. Okay, so network software is actually provided using which like this distributed system software, whatever we are developing, can share this data over the network. Okay, these software, the network software are actually developed and they actually support some common set of protocols. Okay, we'll be discussing about the protocols, okay, slowly when we actually go through these codes, okay, whenever they are necessary. So regarding the protocols are concerned, okay, so what these protocols are, in the context of this communication, protocols must be observed by all the participants. Okay, protocols are some set of rules which you are actually defining, but the thing is like the participating nodes, okay, which are participating, okay, with this protocol must actually stick to this sort of protocol when they are actually exchanging the messages. Okay, so the protocols must be formally defined and they should be precisely implemented. Okay, so each node, whichever is participating in this sort of messaging, okay, should precisely implement this sort of protocols. So for each protocol, there must be some rules that actually specify the following things. So how the data is actually encoded, okay, which is the data which is actually being exchanged between the nodes, okay, how it is actually encoded. So if, for example, like if I'm trying to send some sort of textual message, okay, so what is the thing like, what is the sort of encoding I'm actually taking care while sending the data between these nodes? Say for example, some base 64 encoding or something like that. Okay. One thing you remember, like these videos are not complete on their own. They are actually assuming that you have enough knowledge, okay, enough background knowledge of networks, or you have taken these particular courses, okay. This is basically an excerpt, or like say for example, a quick reminder, okay, so that whatever are required for this sort of distributed computing applications, for developing those applications. So coming back, these protocols, okay, so they need to have this sort of encoding mechanisms, and also like say for example, they should also they must specify how the events, okay, the sending and the receiving of the data, okay, are synchronized, so that the participants can send and receive the data in a coordinated order. Say for example, if I am sending some messages in a particular order, the receiver should also be receiving the data in that particular order. Okay. Okay, if it is not, then what has to be done? The protocol should be talking about the direct things and also like what is the failure cases. Okay, so that's how like error correction is also critical as part of the protocols. But the protocols, the specification of the protocol will define all these things, but it will not dictate how the rules are actually to be implemented. Okay, it is up to the network software to implement these protocols. Okay, there like it has some flexibility how it wants to implement. Okay, the network software. So regarding the network architecture is concerned, network hardware, okay, say for example, all the machines which are actually existing, okay, the network hardware actually transfers electronic signals, okay, which represent basically a bit stream between two devices, okay. So in the internet, like probably you already know about these things, like we are actually using packet switching, okay, it is not circuit switching anymore. So in terms of the how the data is actually sent, probably you already know circuit switching, packet switching, etc. Internet actually uses packet switching. Okay, so the data whichever you are sending, okay, these electronic signals are these bit streams are actually put in terms of packets and they are actually sent across these devices. So the modern day network applications actually require these sort of APIs, okay, which actually mask all these sort of underlying complexities for data transmission. Okay, so if you are sending data, okay, from point A to point B, you are actually sending these packets from point A to point B, but you will not be seeing all the complexity. Okay, so you will have an API which actually states like send this data from application A to application B, okay, or like say for example node A to node B, okay, but it will not be saying like okay divide it into packets and do all sorts of things. I mean like these are the things which are actually taken care by the protocols, okay, and at the network layers which we will be discussing in the next slide. So the layered network architecture, okay, so these are actually put in terms of layers, okay, so the network architecture is put in terms of the layers, which actually allows the functionalities needed to this sort of mask these complexities to be provided incrementally, layer by layer. So as I said, like when you are sending some data from point A to point B, okay, node A to node B, so this data will be actually going across these network layers, okay, so and then like these packets are prepared and the additional information is added to the packets and it is actually sent, okay. But of course, like when you are thinking in terms of the layers, the actual implementations of the functionalities may not be clearly divided by the layers, okay, so you have to remember that. So now let us look at this sort of network layers in general. Okay, probably all of you know about this sort of protocol layers in this Internet Standards Organization (ISO OSI) model. Okay, so it is a 7-layered network architecture. Okay, open system sector connection. It has these layers like physical layer. Okay, at the lowest layer is physical data link layer. Then the network layer on top of it is transport layer, session layer, presentation layer, application layer. Okay, say for example, in this case, like when you are trying to send a message from a sender node to the recipient node, as I already mentioned, like in internet, we are following this sort of packet switch. So whatever the message you are actually sending, it will be put in some sort of packets at the application layer, and each layer will keep on adding additional information to those packets. Okay, and they will be taking care. They are responsible for a particular thing, and they will be implementing those particular protocols. Using which, like eventually, by the time like the and it will come to the physical layer. This is where like the electronic signals are actually sent using this sort of packet switching, and packets are sent. Okay, and these packets are received at the recipient and then like you have to go again in these sort of same layers up so that like the message is actually received at the application layer. Okay, so many things are actually happening across these layers, okay, in terms of this sort of network architecture is concerned. So these, however, this division of this sort of layers is actually conceptual. Okay, so each layer will be responsible for particular things. So they are actually conceptual. That actually makes like allows protocols to be specified systematically. So for example, like physical layer will be dealing with something, data link layer will be dealing with something, and network layer will be actually dealing with identifying those sort of nodes. Okay, how to find those things, and transportation will take care like how the data is actually sent. It will follow certain protocols for that. Okay, similarly the session, presentation, and application layers. So this sort of layered things also allow the programs to be written in terms of logical data flow. Okay, so this is the thing like which we should be remembering. So that's about the ISO OSA network model. In the internet, we will be using this sort of TCP/IP protocol suite. Okay, so the transmission control internet protocol suite is a set of network protocols which actually are mainly used in sort of internet, and this actually supports like 4-layered network architecture. So it will have the same physical layer, internet layer, the transportation layer, and the application layer. So logically, whenever you are trying to exchange messages between two nodes, which are actually implemented using this sort of TCP/IP protocol, so okay, Logically, you will feel like the messages are exchanged across each and every layer, but actually, like still the message has to go from the application layer. It has to basically go to the physical layer where it is actually transferred, and then like you will actually receive it here. So this is about the TCP/IP protocol suite. So we have these sort of four layers at the application layer. Like we have these applications defined. So each layer, of course, the physical layer has to actually send these electronic signals. Okay, so at the end of the day, okay. And then like the upper layer, the internet layer actually implements this sort of internet protocol. So IP basically provides the functionalities for allowing the data to be transferred between any two hosts in the internet. Okay, so the internet protocol actually provides these sort of functionalities. Okay, for allowing the data to be transmitted between any of these two nodes. So for that one, like okay, so it has to basically identify those things. Okay, identify the nodes and all the things, which we will be discussing in the coming slides. Then the transport layer, okay, so which is above this sort of IP layer, okay, internet layer, this transport layer primarily delivers this sort of transmitted data to this sort of specific process running on the internet host. Say, for example, two different nodes are running. Physical layer actually is sending the electronic signals. The internet layer basically implements IP protocol, internet protocol, which actually specifies like how you can actually identify this node and how you can actually send this sort of message to this particular node. So the IP is actually taking care. The internet layer is actually taking care of that one. Whereas like the transportation layer, which is actually above, which actually delivers this message to a particular process. So once again, like the process is a running application on a particular node. In terms of the operating system, you have developed an application which is existing on a machine. When you are started running that particular application, then it is called a process. It will have an ID when it is executed. So basically, like whenever you are trying to send these messages, you are actually trying to send the message to the process. Okay, and this transportation layer actually takes care like how this message which you are sending is sent to that particular machine. Okay, which is taken care by the internet layer to that machine, and then like to that particular process which is running on this machine B is taken care by this sort of transportation layer. There are several protocols for that. Two are very popular. Okay, so one is like this connectionless. Okay, using this user datagram protocol UDP, using which like you will be sending the packets. Okay, so you will not establish a connection between the two nodes. You will be sending the packets destined to that particular node, and then like the node which actually receives these packets will take care of the orders and everything, order of receiving the messages and everything. And then there is other protocol. So this connection oriented protocol, which is transmission control protocol, using which like first you will establish a connection. For that one, like you will have this sort of establishing a connection, you have to receive an acknowledgement, and the acknowledgement has to be okay. So also be acknowledged when then a connection is established. Once the connection is established, using the packet switching, like you will be sending the packets to the other node. This is the TCP. So again, like I am quickly summarizing these things. I am assuming like you already know about this sort of UDP and TCP. Or like when the necessity comes, okay. So whenever we are trying to develop those particular distributed computing applications, okay. So then I will go a little bit deeper into that one based on the necessity. So that's about this sort of transportation layer. The upper layer is the application layer. Okay, at the end of the day, like it is the applications you are developing which are actually exchanging the messages on these particular two nodes, okay, over the internet. Okay, so the application layer actually supports programming interfaces used for building a program. Say for example, now if I want to develop an application, I will not be developing that application from scratch. Okay, even at the application layer I will be, so the network software already provides me some built-in software for me. Okay, say for example, SMTP, simple mail transfer protocol. Okay, so using which like I can send email messages. So basically what I will do is like if I am trying to develop an email-based application, okay, so I will follow this sort of SMTP protocol, which is actually implemented on this application layer. Using that particular protocol, I will be developing an email application using which like I will be sending the mails to other nodes. Similarly, file transfer protocol FTP. So using which like if I am trying to transfer some files, I'll be using FTP. HTTP hypertext transfer protocol. Okay. So this is like using which like we have all these sort of websites developed. So all this sort of internet-based, web-based communication. Okay, follows this HTTP protocol, HTTP and HTTPS. Okay, secure protocol. So these protocols are already implemented at this sort of application layer, using which like I will be developing my own applications which I will be following these sort of protocols. Okay, the network software, most of the things are already provided for you. The API is already provided for you. So that's about this sort of network layer and how you will be actually exchanging the messages. So regarding the reference are concerned, again, this is an excerpt from chapter 1 of distributed computing principles and applications. Okay. And also some things are taken from chapter 3 of Coloris et al. Distributed systems, concepts and design. Okay, that book. Okay. And some of the networking concepts. Okay, so I have also taken from Bonaventure. Okay, so computer networking principles, protocols and practice. Thank you very much for your attention.